Guys, welcome to example 6, our last example for the morning. I hope you found these videos to be helpful. In our last example, we are given a boat that's being pulled into a dock by a rope attached to a bow through a pulley. We're given a couple of quantities that we must recognize. The first quantity that we're given is that the boat, that the dock is 1 meter higher than the bow of the boat. So this quantity is 1 meter. The other thing I want you to notice about this quantity is not changing. The distance between the pulley and the dock does not change. Okay? So I want you to make reference to that. The distance between the pulley and the dock does not change. And I'm going to go ahead and call this quantity y. This distance is 1 meter and it's not changing. So remember that. That's important. It's 1 meter and it's not changing. The other thing that they gave us is that the rope is pulled in at a rate of 1 meter per second. This quantity, let me circle that in blue. This is the rope. And it's being pulled in at 1 meters per second. So if I call this rope z, then dz dt would equal to 1. And the last quantity they ask us for is they want to know how fast this is changing. How fast is the boat going into the dock when x is equal to 8, when there's 8 meters left? How fast is this moving toward the dock? Okay? So this, what we're looking for then, if I call this 8, then what we're looking for is dx dt. That's our unknown quantity, and we're trying to find that when x is equal to 8. Our y is 1, and our dz dt, that's a weird looking y, our dz dt is equal to 1 meter per second. Yes, 1 meters per second. And I'm going to fix that y because it's creeping me out. Okay, so those are the quantities that we have. We're looking for dx dt when x is 8. We know that y is 1, and this is a constant. It's not changing. And dz dt, the rate at which the rope is being pulled in, is 1 meters per second. So, given that this makes a right triangle, I know I've circled a lot here. It's kind of hard to see, but this is a right triangle. The formula that I can use to relate everything together is Pythagorean theorem. Okay? And once again, this is called the applications of derivatives, so let's take the derivatives of this quantity. So taking the derivative of Pythagorean theorem, I get 2x, remember we got to use implicit, so 2x dx dt plus 2y dy dt is equal to 2z dz dt. Okay? So I need to figure out, what do I know? I know dx dt. I know x is 8 at that moment. I don't know dy dt. I know y is 1. I know dz dt, but I don't know z. But let's talk about what dy dt is for a second. Remember I told you that the distance between the pulley and the dock, that distance is 1 and it's not changing. So since this distance is unchanging, dy dt is 0. And if y dt is 0, then that makes this entire quantity 0. Okay? So now all I need to know is z. And to find z, I go back to the Pythagorean theorem. X squared plus y squared equals z squared. So I know that x is 8. I know that y is 1. And I don't know z. But now, doing some math, I can see that z is equal to the square root of 65. So now I have everything I need to solve this problem. I know that x is 8. I know that dx dt is, I'm looking for that. I know that z is now the square root of 65, and dz dt is 1. So solving for dx dt, I get dx dt is 2 square root of 65 over 16. Or dx dt is equal to radical 65 over 8. And that would be in meters per second. Okay, that's our last video for tonight. I hope you've enjoyed these videos. Please try to do your homework. Please attempt your homework. I think you have 10 problems for homework. Try setting up the quantities. Do as much as you can. And, of course, I will answer any questions that you have on Monday morning. Have a great weekend, and I look forward to seeing everyone on Monday.